This photograph by Mark Brett currently holds the Guinness World Record for the longest line of sight photographed on Earth. Mark took this from the top of Pic de Feinstrals in the Pyrenees, and this mountain here is the top of Pic Gaspard, which as the crow flies is 443 kilometers away in the French Alps. Now, this particular photograph has been cited to me on numerous occasions as proof that the Earth must be flat, when actually, when you break it down, it proves the exact opposite. So let's first address why flat earthers say it proves the Earth is flat, then why it's actually possible on a globe, and then afterwards we'll cover how it actually supports the globe. So, Pic Gaspard is 3,833 meters high. Using flat earthers' favourite equation of 8 inches per mile squared should mean that the summit of the mountain is 11,848 meters below the horizon, and so completely out of sight, and therefore we can't be on a globe. However, the 8 inches per mile squared formula has a few flaws in it. Firstly, it's only a rough guide of curvature using a parabola formula. It's not the exact formula for the curve drop of a circle. Secondly, it's based on the curve drop from an imaginary tangent at ground level where you're standing, so you would go straight out 443 kilometers, and then how far down the ground would be from there. But that's not how we look into the distance. The formula doesn't factor in our elevation, which in the case of this photo from the top of Pic de Feinstrals is 2,826 meters above sea level. We also don't look out perfectly perpendicular to where we're standing. We look sort of down on an angle to the horizon and then beyond it. So such a curve calculation drop should really be more from where the hump in the horizon is that objects begin to disappear from, not from where you're standing, unless you're lying down on the ground at sea level. So if we use a more accurate curve drop calculator that is based on the formula for a circle, and does in fact account for the viewer's elevation, then the summit of Pic Gaspard should be 1,147 meters below the horizon. Significantly less than the 11,000 meters that the 8 inches per mile squared suggests. But, still below the horizon, which flat earthers will say proves that the Earth must be flat. Except this calculator doesn't account for atmospheric refraction. These are simplified calculators working on just a basic circle. It's like when we used to do physics experiments in high school, we were always told to just ignore air resistance, or that the speed of light is 186,000 miles per second, when that's only its speed in a vacuum, and its speed actually varies through different mediums, but for simplification, we just stick with 186,000 miles a second. So these are only simplified curve drop calculators. They don't account for atmospheric refraction. Now, flat earthers seem to hate the notion of atmospheric trickery explaining a globe, yet they call upon it to explain how the sun manages to drop below a flat horizon. But that's a whole nother topic for a different day. The speed of light changes depending on the medium. Generally, the denser the medium, then the slower the speed of light. And if the light moves between these mediums at an angle, then it causes the light to change direction, which is called refraction. This is the basis of how camera lenses work. They're bending light as it passes through various shaped glass elements in order to get all of the light to land together on the camera sensor. Now, we get atmospheric refraction as the sunlight travels through the vacuum of space, and then it's passing through gradually denser and denser atmosphere. And when the sun is very low in the sky, then the light is gradually shifting through these pressure gradients, causing it to bend slightly. And actually it makes objects appear rather distorted and squashed in shape. It's why when you see a sunset, the sun often appears to get squashed as it reaches the horizon. And at that point, the sun isn't actually there. I know, flat earthers' heads are about to explode with that statement, but the sun by that point is actually below the horizon. What you're seeing is just a heavily refracted version of it being bent over the curvature of the Earth. As a demonstration, here's a glass of water. Now the glass curves the light, and the light is being refracted in the process. So now objects that are behind the glass are, well, one, they're basically being mirrored because the light is then further being refracted by the other side of the glass. But you will notice that as the object reaches the edge of the glass, the refraction hits its peak, and the object becomes heavily distorted. And it actually still appears within the confines of the glass, even though the object itself has passed well beyond the glass. Now, I know this isn't a perfect representation because the Earth's atmosphere doesn't mirror what we're seeing like looking through a glass. Really, a curved fish tank probably shows it better. If we imagine the curved front of my fish tank here is the curvature of the Earth's atmosphere, the fish is still visible within the curve despite it actually clearly being well below the horizon. This refraction is also what causes the flat earthers' infamous black swan evidence, with an oil rig being visible far further than it should be. But you can clearly see the huge amount of compressed distortion that's being caused by this because of refraction. Anyway, back to Pitt Gaspard. If we look at an advanced curve calculator that actually factors in refraction, you can see that even with standard levels of atmospheric refraction, there should be 26 meters of the top of Pitt Gaspard still being visible over the horizon. Now, obviously, we are seeing far more than 26 meters in this photograph, but the amount of refraction can vary depending on the refractive index of air at that time. And the refractive index of air varies on the air pressure, the humidity, and the temperature. And these can cause the refractive index to be higher. So if we increase the refraction level slightly on the calculator, you can see the visibility of the target actually increases quite significantly. And this is even highlighted in the write-ups for the image, the extensive planning for the right time and location, and the favourable conditions in terms of high refraction, making it possible to see Pitt Gaspard from that spot. Usually, it's not visible, which is why seeing such extreme distances only happens on certain occasions when everything lines up right, not all the time. Now, let's get into how this image actually proves the curvature. It's not just Pitt Gaspard in this image, there's actually several other peaks either side of Pitt Gaspard. To the immediate right is Rocher Ronde, and to the immediate left we have Grand Ferrand. Now both of these are almost identical distances from the point that the picture is being taken, yet Grand Ferrand is 303 metres higher than Rocher Ronde. So this gives us a clear reference as to what a 300 metre height difference looks like from this distance. We can also note that from this perspective, Pitt Gaspard seems to be the same sort of height as Rocher Ronde and significantly shorter than Grand Ferrand. But Pitt Gaspard is over 1,000 metres higher. Now, yes, it's further away, so you could argue it's perspective, but perspective causes objects to shrink directly proportional to the change in distance, i.e., if you double the distance that an object is from you, then its apparent size roughly halves. From our vantage point, Pitt Gaspard is 13% further away than Grand Ferrand, yet it is 40% taller. Now, on a flat surface with no curvature, the viewing angle for Pitt Gaspard should be 1,800 arc seconds versus 1,451 for Grand Ferrand, so Pitt Gaspard should look taller, yet it actually appears significantly smaller, and only appears the same size as a mountain that it is 57% taller than. Yet when we plug those figures in for Grand Ferrand and Rocher Ronde into an advanced curve calculator, the results correlate with what we see. Rocher Ronde should appear a similar observable height to Pitt Gaspard, and Grand Ferrand should appear much taller. So the key to why a significantly taller mountain like Pitt Gaspard is appearing the same size as a much smaller mountain is because it is 49 kilometers further beyond the horizon, which puts the whole mountain further beyond the curve and so relatively much lower than our vantage point. So there you have it, a record-breaking photograph which gets used as evidence for a flat Earth that actually proves the existence of curvature. And that is going to wrap this video up. As always, thank you so much for stopping by, and hopefully we'll see you in the next video.